So let's take this function, f of x is x squared plus 1 divided by x plus 1, and let's represent it in a table. So, of course, we can't truly represent this whole function in a table because a table only has a finite amount of data in it, a finite number of rows. And the domain of this function is certainly infinite, right? So there are infinitely many possible values that can go into this function. You can see the only possible problem is that x plus 1 being 0, so x is equal to minus 1 is the only problem point. Every other number is totally fine. So the drawback of a table, of course, as I said, is it's not going to show the entire function, but we can give some partial information, I suppose. So I'll just choose a few values. So x and f of x. I don't know, let's do 1. So what's this equal to? Well, if I feed in 1, so let me just off to the side, this would be 1 squared plus 1 divided by 1 plus 1. That's of course equal to 2 divided by 2, that's equal to 1. So here we would have 1. Very nice. Let's feed in 2, see what happens. So 2 squared plus 1 divided by 2 plus 1. That's equal to 5 divided by 3, is that correct? Very nice. Let's feed in another one, I don't know, let's do minus 2 maybe. So if I feed in minus 2, it's minus 2 squared plus 1, all divided by minus 2 plus 1. So this is equal to 5 on top again, because minus 2 squared is the same as 2 squared. Minus 2 plus 1 is minus 1. So what does this come out to be? Minus 5. So it's minus 5 here. So there's not much more to it than that. Tables are useful when you have, you need to get very specific values quickly, right? Or if you're dealing with experimental information, so a function coming from data, from an experiment, and you don't have a nice neat formula, but you do lose a lot of information relative to the formula. The formula is like the most powerful way to represent it, really. It may not be obvious what its properties are, but it's a very succinct, very precise description of what the function is.